Example 2, find the missing parts of the triangle. I want to go through this one quicker because it's basically the same problem as the last one was. Because if we take a look at this, find the missing parts, I know a side, I know an acute angle, it's the exact same information, so we're going to use the exact same technique. Alright, we're going to use this. So again, right now what I want you to do is have this yellow sheet in your presence so that when you need to use it, you can look it up. Ideally, as we get further along in this, our test over this is going to be till probably, that might be the Tuesday before Thanksgiving when this test is going to happen. So the point is that you've got about a week and a half to get this under control. You're going to get lots of practice problems to do this. Have it out, but use it as you need it. Okay, hopefully you get to a point where you don't need it anymore. You can just know what you're supposed to do. So step 1, find the other angle. So B is equal to 180 minus 90, which is this angle, minus 35, which is that angle. If we do that, we're going to get 55 degrees. And just like that, we get one of the answers pretty easily. Step 2, pick an angle and determine the opposite adjacent hypotenuse for that. Which angle do we want to pick?
35.
35 is fine with me. Keep in mind, we know this is 55 also. We could use that if we want to. 35 opposite side is x, because we go across the triangle. We go across from the right angle. That's the hypotenuse. The third side has to be the adjacent side. Okay. Then we move on to step 3, Sohcahtoa. Before I write Sohcahtoa of the sine, cosine, tangent, can anybody tell me which one is not going to be helpful this time?
Tan.
How do we know?
Because it's just two variables.
The opposite side is x, the adjacent side is m. These two sides which involve this are the unknowns. That'll get us 2 letters, that's no good. So if you want to only write 2 trig ratios, make sure you write the 2 that count, alright? And Brady said before, because I moved things around, I couldn't do that on my paper. If we do this up front, and then we know we just need to do sine and cosine, sine of the angle 35 is equal to opposite x over hypotenuse 14, put that over 1. There's sine. And then cosine is cosine of the angle over 1 is equal to adjacent over hypotenuse, that's m over 14. Okay, so if you up front realize what's going to happen, you can go ahead and make your paper look like I had the last one, right? Again, I'm going to harp on this right now because right now is where people start messing up. Trig ratio named sine or cosine in this case, sine of an angle equals ratio, opposite over hypotenuse, opposite x over hypotenuse 14. Cosine of an angle, 35, the one we chose, equals adjacent side over hypotenuse, that's m over 14. Put both trig ratios over 1 to create this nice proportional look because, again, proportions cross multiply. Once again, I don't know what sine of 35 or cosine of 35 is, so I'll type in my calculator. Sine 35 equals, cosine 35 equals. So 0.5736. So sine of 35 is 0.5736. And cosine of 35 is 0.8192. Alright? Again, those are whatever they are. You don't have to know what the cosine of 35 is. Your calculator does. Just make sure you write it down correctly and make sure you round it. 4 decimal places. Okay, in order to get the answers, step 4, solve the proportions. This product x equals this product. I don't know what that product is, but my calculator knows 0.5736 times 14 comes out to 8.03. And this proportion here, 1 times m is m, and again 0.8192 times 14, I have no idea. 0.8192 times 14, that comes out to 11.47. Okay, just real quick, I want to throw a couple things out at you. What kind of triangle is this? Right triangle. So the Pythagorean theorem should be valid, right?
Yeah.
So I had no idea what x and m were, but I figured them out, right?
Yeah.
If this is truly correct, if I do this squared plus this squared, I should get close to 196.
Yeah.
All right. I won't get exactly 196 because these are rounded. But again, if I square this and add them together with the Pythagorean theorem, x squared plus m squared should equal 14 squared. We try it out. 8.03 squared plus 11.47 squared comes out to 196.0418. Almost the same as 14 squared. squared, right? 14 squared being 196. Again, approximately, because these are approximate, that's how you handle that. That's a quick way to check these. If you do the Pythagorean theorem and it's valid, chances are you got your sides right. Other thing I'm going to throw at you real quick, just in case anybody wants to do this, this was a 55-degree angle. So if I did, this is the opposite side, and that's the hypotenuse. Let's just work with that. So 55-degree angle, opposite, and hypotenuse. That means sine of 55 over 1 is equal to the opposite m over the hypotenuse 14. Anybody want to take a guess what the sine of 55 is? What does m equal?
11.47.
And that equals 11.47 because 0.8192 times 14 made m, right? This times 14 is supposed to make m, right? This better be 0.8192, right? Let's try it out. Sine of 55 equals 0.8192. For that matter, cosine of 35, or was it 35? No, they're the same. All right? That's why it doesn't matter what angle you pick. The sine of one angle is equal to the cosine of the complementary angle, and vice versa. So it doesn't matter just as long as you do it correctly. So in step 2 where I said pick an angle, that's what I mean, pick an angle. Don't change your mind. All right? You change your mind, bad things happen. But whatever this angle is, that's the same angle. It doesn't matter which angle you pick, you can get the same answer. This would have been 0.8192, and this would have still gotten you m is equal to 11.47. That would have been cosine of 35 or 55, which would be 0.5736. So again, it doesn't matter. Pick an angle, make a choice, stick with that choice, and you'll be in fine shape.